Okay, last part C, exact same process. We have f of x equals the log natural of x squared times the cosine of x. And our a to b is e to 5e. So in y1, we're going to put f. In y2, we're going to put the derivative of f, which is our first one times the derivative of our second plus the second times the derivative of the first. We've got to use the chain rule with the power rule. So we bring the power down first, and then we multiply by the derivative of the inside. Multiply that together, I get a negative sine x times a log natural of x squared plus a 2 cosine of x times an ln of x over x. So, moving to the calculator now, we will clear out what's in there. And in y1, we'll go put our function, our original function, which is the log natural of x, quantity squared, times the cosine of x. Then in y2, we're going to put that same ln of x squared times negative sine of x plus 2 times the cosine of x times the log of x divided by x. And we'll put parentheses around the top. I don't know that it'll make a difference. And we'll hit enter. So it looks like we have our log natural of x squared times the negative sine of x and our 2 cosine ln of x over x. Okay, so that's in good. Now our goal is to figure out what y3 is going to be. Remember, y3 is the secant slope. So we'll go to our home screen to compute the secant slope. It will be the difference in y's over the differences in x's using our a and b from the problem. So y1 of b, that's 5e. Notice it inputs the power, so you can either put a power of 1 or you can just erase that power. Then we need to subtract y1 of e, so diamond e, backtrack and close. Now close the top and divide by, we need 5e minus 1e, that's going to be 4e. Diamond enter to see what the value is. We get something really close to a half. So that means we need to put that number into our y3. Now in this case, it's probably going to be easier to grab that number and store it as opposed to writing that number down and then transferring it into the y editor. So if you come up and turn it black and hit enter, then it will put the whole number on the screen, and then you can store it. Let me show you the store button. You can store it to y3 of x. When you do that, it will put it into the y editor for you. So we hit enter and we go to our y editor, and you can see there's that number in y3 that we just stored. So let's recall, when we're looking for the number of times that the mean value theorem is satisfied on the interval, we need to graph the tangent slope and the secant slope. We don't want to graph y1. So we come up to y1 and turn it off using F4, and now we need to set our window. The window will be from A to B in the x range, so that will be E to 5E. And then my y max and y min, I need to be able to see that 0.4. So I need to flank 0.4, be above and below it, but if I get too far away from it, I'm not going to be able to differentiate between that horizontal line at 0.408 and the axis. So what we do is we get close on both sides. So we could probably go from, say, negative 0.8 to positive 0.8. Now if I graph, we can see here's our regular axis, here comes our derivative, And now here comes our secant slope. And we can count how many times it intersects. 1, 2, 3, 4. So back in the problem, we have 4 values of C. Long problem, but we're done.